Good morning everybody, I am Sridharreddy. Today my topic is molecular velocities. So gas will have the large number of the tiny particles and those tiny particles is called the molecule. Let us take, I am taking the gas which is taken in a vessel which has the large number of the tiny particles and these particles is called the molecules, and each and every particle will have some velocity. Let us assume the velocity of the molecule, first molecule is the u1, second molecule is the u2, so on n molecule whose velocity is the un. So in order to calculate the molecular velocity of the gases, we have three types of velocities. Generally the gas velocities, gas molecule velocity can be calculated by using the three methods you are having. One is called the RMS velocity, which is represented with the C. Number two, average velocity, which is represented with the C bar. Number three, most probable velocity, CP. So these are the three methods you are having to calculate the velocity of the gas molecules, and simply I am taking the first one which is called as the RMS velocity. In order to explain the RMS velocity, we are taking the gas in a vessel which has the large number of the tiny particle, and the particle velocity, if you observe u1, u2, so on, the un you are having immediately. C RMS velocity is represented with the, let us take here, I am going to take this one, u1 square plus u2 square plus so on, u2 square plus so on, un square divided by n. So this is the RMS velocity. By this mathematical equation, we can say the definition of the RMS velocity, whose full form will be the root mean square velocity. RMS velocity, root mean square velocity. Let us take here. What is this one? The definition, if you observe, square root of mean of square velocities. U1 is the velocity. U1 square is called as the square of the velocity. So sum of the square of the velocity divided by the number of the molecule, which is taken as the under root, which is called as the RMS velocity. RMS velocity is called as the root mean square velocity. What is the definition? Square root of mean of square velocity is called as the RMS velocity. This is the definition of the RMS velocity. Once again, square root of mean of square velocities is called as the RMS velocity, which can be calculated by using the mathematical equation. If you observe, it is calculated by using the 3 PV by m. Already we are familiar, PV is equal to nRT, where 1 mole of the gas, if you observe, RT. So in place of the PV, I am taking the 3 RT by m, which is the another form of the C value, can be calculated by using this also. Another value, if you observe here, if you take V by m, already you are familiar, density is equal to mass by volume. V by m is nothing but 1 by d, nothing but 3P by d. So these are the principles which are used to calculate the RMS velocity, and under root of 3PV by m, 3RT by m, under root of 3P by d. Whenever he gives you the volume, pressure, mass, you have to take this one. Temperature and the mass, then you have to take this formula to calculate the RMS velocity. Simple. Then average velocity. Average nothing but, already we are very familiar. Average velocity is nothing but, it is equal to the sum of the velocities to the total number of the molecules. Sum of the velocities to the total number of the molecules, which is called as the average. Generally we will take average. What is the average? Sum of the velocities to the total number of the molecules is called as the average velocity. That's why sum of the velocity is given as u1 plus u2 plus so on by n you are having, which is called as the average velocity. How to calculate the average velocity? By taking the mathematical formula, C bar is equal to under root of 8 PV by pi m. 8 PV by pi m. Again, PV is equal to nRT. So 8 RT by pi m. Again, V by m is equal to D. So 8 P by pi D. So this is the equation you are having immediately. What is the relation between the C bar and the C? C bar and the C. And the C bar is equal to 0.9213 into C. Very, very important for your MCET examination. He gives you the RMS velocity is 10 and calculate the C bar. C bar is equal to 0.9213 into RMS velocity. This is about the RMS. CP. What is the CP? Most probable velocity. Let us take here. In this gas molecule, we have large number of the particle. 80% of the molecule velocity is 10 meters per second. Remaining 20% of molecule is the 5 meters per second. Nothing but maximum number of particles is having the velocity 10. The maximum number of particle velocity is taken as the most probable velocity. Nothing but most probable velocity, nothing but the velocity possessed by the maximum number of molecule. Velocity possessed by the maximum number of the molecule. Here in case 80% of the molecule is possessing 10 meters per second. That's why the velocity of the gas molecules is taken as the most probable velocity, which is taken as the 10 meters per second. So nothing but the definition is the velocity possessed by the maximum number of molecules is called the most probable velocity, which is represented with the Cp, and the Cp is equal to under root of 3 PV by m. Look at here, 3 PV by m, it is the 2 PV by m, which is equal to, again PV is equal to nRT, so 2 RT by m, V by m is equal to D, ultimately 2P by D immediately. What is the relation between Cp and C? Cp and C. Cp is equal to 0.8166 into RMS velocity. Very important. C bar is equal to 0.9213 into C. Cp is equal to 0.8166 into C you are having immediately. What is the relation between these three? Relation between these three. I am taking relation like this. Cp I am taking first, C bar and C. So I am coming from the bottom. Cp is equal to what you will write? 2 RT by m. 2 RT by m. Here C bar is 2, 8 RT by pi m. This will be the 3 RT by m. 3 RT by m. So good. RT by m, RT by m, RT by m. Ultimately what you are having here? Root 2 is 2, root 8 by pi is 2, root 3. I am dividing the entire thing with the root 2. Ultimately here you will get 1 is 2. 1.128 is to 1.224. So this is a relation between the Cp, C bar and C. Cp is equal to 1, then the C bar is equal to 1.128. If the Cp is 1, ultimately RMS velocity equal to 1.224. Ultimately by using this one we can say which will have the high value. C will have the higher value than the C bar will have the higher value than the Cp. Ultimately the order is given as C is greater than the C bar is greater than the Cp. This is the order you are having, and the equation if you observe 1 is to 1.128 is to 1.228. If you observe C bar will have 1.128, then the Cp will be 1. Nothing but C bar is equal to what we can write 1.128 into Cp. You multiply with the 1.128 into Cp, you will get C equal to, C is equal to with respect to Cp. It is equal to 1.224 into Cp. So this is again two relation. 1.128 is to 1, nothing but C bar is equal to Cp into 1.128. C bar is equal to Cp into 1.224. Like this you are having the relation. This relation is the 2 marks question in the IP examination, and these two, 1 and these 2 are the important for the MSET examination. Now look at here, how the question arises in the examination. How the question arises in the examination, MSET examination or IP examination. Calculate the RMS velocity of the carbon dioxide at 27 degrees centigrade. 27 degrees centigrade. Immediately. Degrees is given, that's why C is equal to under root of 3 RT by M. Here, under root of 3. R value, which value you have to take? If you take the R value in the joules, 8.314, then the answer will be the meters per second. If you take the x into 10 to the power of 7 x, then the answer will be the centimeter per second. Into T, 27 degrees centigrade is converted into the kelvins, which will be equal to 300, divided by molecular weight of the carbon dioxide. Molecular weight of the carbon dioxide is the 44 grams. But you are taking the meter per second, I think it must be converted into the kilograms. That's why it is equal to the 44 by 1000. Then simplify it, you will get the C value, which is called as the RMS velocity. Whenever you know the C value, we will calculate the C bar. Whenever you know the C value, we will calculate the Cp also. Here I will give you one shortcut for your MSET examination. C is equal to 1.54 into root T by M into 10 to the power of 4 centimeters per second. This is a shortcut to calculate the RMS velocity. T, temperature 300, mass nothing but 44 centimeter, nothing but just you take the 44 only. Here I am taking the 8.314 joules SI system, that's why 44 grams must be converted into kilos, 44 by 1000. Here no need to substitute anything, just you substitute 1.54 into temperature is the 300 divided by mass is the 444 into 10 to the power of 4 centimeters per second you will get. So these are the velocities can be calculated by using the three method. One is the RMS velocity, root mean square velocity. Second one is the average velocity. Third one will be the most probable velocity. Thank you.